For this process, you can use any CAD software like AutoCAD, MicroStation, or OpenRoads. The only requirement is that you should be able to export .dxf format out of that drawing. In this example shown in the screen, I will be using this bridge base map of a two-span skewed curved bridge, and I will show you how to prepare this drawing for the importing process. I will be using OpenRoads Designer for this example. This is a bridge base map, and I will be turning off all other references which I don't need. So I basically need the beam centerline, diaphragms, and deck edge. So I've already done that, and I will open that drawing. Now, this is the refined drawing. I will only be modeling superstructure, so I only need beams, deck edges, and cross frames. These three lines, the one right here, the one at the forward abutment, and the one in the middle are the center lines along bearing. And we have inclined the skewed diaphragms at these locations. So I will just delete these bearing lines because I don't need these. And these two lines are splice locations. I intend to put a node at the intersection point on the beams so that I can start a different section in this negative moment region. So I'll just keep it for now, just for the purpose of providing a reference point. I don't need this center line of construction, so I will delete this too. But I will just keep it for now because I don't have any beam line there. So I will just change the layer. So what I will do is change this layer to the beam layer because the beam line and the center line of construction are overlapping. Okay, so I have 5 beam lines, and this is the deck edge, and this is the splice location, and we have diaphragms. Most of the diaphragms are normal, and the one at the support are skewed. And the other thing is, I'm not going to model anything beyond the bearing lines, or in this case, be anything beyond the skewed diaphragms. So I will just trim these like I have in the middle. So I will just extend it up to the bearing line or the diaphragm location. And same on the other side. Okay. Also, I will delete this deck edge line, which is beyond the bearing line. So I'll just delete this on both sides. And now I will draw another line, that shows the end of the deck. I'll draw it like this and just extend it up to here. And similarly, I'll do the same here. Like this and this. Now for finite element analysis, we will divide our beam into number of elements. To determine the number of elements, you should consider two factors. First, how accurate results do you want? And the second, the analysis time will go up with element numbers. In our case, here I will just divide beam elements based on the intersection between other structural components rather than dividing into random number of elements. But you can divide it in as many parts as you want, like I said earlier, but you should be careful about the analysis time and the amount of effort that goes with increasing number of elements. So as I said, I will create elements between the intersection point between these structural components. This will ensure that I have a node at the intersection point between diaphragm and beams. The other thing to keep in mind is that since these beams and deck edges are curved, we cannot use curved beam elements. These elements should be replaced by straight lines. If you use curved elements, the Midas software will make them straight and you may not have correct structural model. So we need to draw these elements using a straight line element. And to do that, what I'm going to do is I'm going to select a layer. I will use a beam layer instead of using center line like I have right now. Proposed beam object. And what I will do is for this first beam, I will just connect these points. That means I will just basically draw my beam elements, straight beam elements between the points where I want to draw them. And this is another reason I kept the splice location is because I want a node at this point so that I can change the, so that, another element begins at this point and I can have a different section for the negative moment region. And like this go on. Okay, so we will repeat this process for all 5 beams. So as you can see, I have drawn all my elements. Now I will delete the splice locations and also the underlying beam center line. It is beam location. Okay, so this is what we have so far. And now let's talk about the cross beams. Since we are using Grillage method, we need transverse members, also known as cross beams, to transfer load from the deck. Basically, it should mimic deck rigidity or stiffness, but not the weight. The common approach is to use cross beams that are 5 feet wide, but you can use any width of those cross beams. But I'm gonna use 5 feet for this example. To see how Midas Civil Wizard does model cross beams, I did a quick modeling of a simpler curved bridge using Wizard tool and found out that Wizard actually draws 5 feet cross beams based on 5 feet width at the center line of the bridge. So you will have half portion of the bridge uh, that will have gap between the cross beams and the other half portion down here near the tighter radius will have overlapping. I think that's pretty smart to balance out a cross section. So we will use the same approach and draw 5 feet width at the center line of the bridge. So let's take a look at this model up here. This is the model that I was talking to you that I modeled just to see how cross beams are modeled in Midas Civil Wizard. So I have only cross beams selected here. And let me turn on the sections. So if you take a look here, um, in the top portion, you can see gap between the cross beams. And if you look at the bottom here, you can see there is overlapping between the cross beams. This is because of the tighter radius in the inside face, because I'm using constant 5 feet wide cross beams, so it's not gonna be exactly side by side throughout the curve because of the varying radius. So yeah, this is the approach we are going to use for our modeling as well. So now let's take a look at the spreadsheet. I'm using radius of center line of the bridge and calculating the angle corresponding to 5 feet width. Now I will draw a line normal to the curve and rotate that line by this angle throughout the bridge. So now I will draw a line normal to the curve and extend this line all the way to the other end. And now, as I said earlier, I will rotate this line with 0.25 degrees, which is basically 15 minutes. And when you have positive angle, it will go towards the left, towards the counterclockwise direction. So to go to the clockwise direction, I will make that negative and rotate it from the center of the arc, and I'll just click it. Now you can see I have my cross beams drawn, and I also need cross beams in this direction, so I will go back here and do negative to get the counterclockwise direction, and I will do the same in the other side. Let's check to see if there is no repetitions. I think that's fine. Yep. Okay, so now I will just basically trim these lines. Before that, I will just delete whatever is beyond the bridge. We don't need that. I think that's fine. And now I will just trim these lines. And this one. And also right here. And a few more here. Okay. Just to make sure these lines are extending, these cross beams are extending all the way to the other side of the other edge of the deck, I will just extend these lines using the extend command. And few lasts. Okay. So this is how you draw your cross beams. Now in this model, we have two skewed cross beams at both ends, one at the rear abutment and another at the forward abutment. Uh, these cross beams are there to cover gaps between the end cross beams. When I say that, let me show you my widget model. You can see here there is a triangular gap left between each cross beams at the each end of the bridge. So just to make sure we cover this space, I'm just gonna use skewed crossbeam at each end of the bridge. Let's now talk about the edges of deck on each sides. This one right here and this one. These are not cross beams, but we will still keep these in our model to represent a complete bridge model in Midas. These outer lines will not contribute to either rigidity nor weight. We will make their weight 0 and area a very small number, which is approximately 0 because we can't input area of any section as 0. We will also use a different layer for these outer lines. So I'll just put this in default layers. Now there is one last thing that is left. to be done is to delete this curved line and replace it with straight lines between the intersection points. And to do that, I will still use the default layer because that's where I want to put this element in. So I'll just say place line and use intersection snap and just connect, draw a segment between these intersection points. So I have deleted the edge curved line and replaced it with small segments of straight beam elements. Thus, we can now export this model out of OpenRoads and then import it to Midas. Before exporting this file, make sure you don't have anything else other than what you intend to import. So if you do zoom extend, I don't see anything else here. And also let's take a look at the layers. You can see the only layers that the OpenRoads show is being used are these 4 layers. The default layer is the edge of deck, and these are the beam objects, and these are just cross frames, and these are cross beams. Sometimes some unused layers show up in Midas, so remember which layer contains what. Also, I would like my origin to be at the mid of the bridge, right at the start point, so that it's helpful me to make a reference while working in Midas. So let's find the origin. In OpenRoads and MicroStation, you can quickly do that by using key in feature. Type x, y is equals to 0 space 0, and then click on place line. Oops, let's do it again. Select place line, and then x, y is equals to 0 space 0, and enter. Now you can see the line is starting from the origin. So I'll just draw it somewhere. And then I will move my bridge right at the origin. And I'll delete this line. So what happens is, when you do this, this model's origin will coincide with Midas Civil's origin. One thing that I forgot to do earlier is to group my beam portion in the negative moment region. We need to select the portion of the beam that's going to use different section and put it in a different layer so that it's easier to assign section once we import this CAD file to Midas. For this, we'll turn off the cross beam and look for that splice location. We created intersection node at the very beginning. If you remember, it's right here. So what I will do is I will just draw a line actually right here and just extend this for now. I will copy this and find the same point on the other side. So yeah, it will go through the same intersection point. So what I will do is I will select the beam portion that's in the middle. And now I will put this in a different layer. I will say beam. Let's put this in beam structural detail layer. The important thing is it doesn't matter which layer you use, but you should remember which layer has what structural components. select none. You know what? I'll change the color so that it looks a little different than the diaphragms. Um, Maybe I'll use. We have slab as green, so maybe pink. Okay, and now I'll just delete these lines, and I will also turn on the cross beams. Okay, now we are done. Now what we'll do is we will export this drawing out of this CAD file. So go to File, Save As, and select the .dxf format, and I will just name it as Midas file and save. And it will ask for a unit. It doesn't matter which unit you choose. So I will just use survey feet for now and click on OK. So this is the .dxf file that I created. Now I will close this and open my Midas file. Let's now open Midas Software, and since we have already created a new file or project, now we'll go to File, Import, and click on AutoCAD DXF file. And here we will browse for our Midas DXF file, and this is the Midas file that we created. So click on Open. And as I said earlier, we will see more layers than what we used, but this is no big deal because we know our layers and we know which layers contain what elements. So let's start importing our members. The BRP beam elements contain beams in positive moment region. So let's select this and click on apply. And one more thing, you don't have to worry about material or section because we haven't defined them yet. So it's gonna take one as a default. And once we define material and section properties, we will assign them based on their group. So for now, just select the beam elements and click on apply. Now you can see here, we have beam sections in positive moment region, but we are missing beams in negative moment region. So now we will unselect this, send it back, and we remember beam structural detail has beam sections in the beam element in the negative moment region. So I will select this, click on apply, and that completes our beam lines. Now let's import cross frames or diaphragms. But first unselect this and select cross frames and click on apply. Now we have cross beams. To do that, unselect this first and then click on slab, select this and click on apply. And we have our edge element. So edge of deck, select that, click on apply. And that's pretty much. We will ignore all other layers because they don't contain any of our elements. So I will just close this. Now, if you look in the message window, you can see that there are warning messages saying some elements are overlapping. We know that already because our end skewed crossbeam and skewed diaphragm are at the same location in 2D. But in 3D, when you assign section properties, they will be in different planes and it will fix this issue. So you don't have to panic when you see this message, but you should understand why this is showing this message. And for example, if you want to take a look at like which element is this talking about, so that you know where the warning message is coming from, let's say it says element 223 and 63. So you can go up here and just type 223 and click enter. As you can see, it's displaying this red highlight over the element. and that's 223. If you come here and display element numbers, this is element 223 and the is overlapping with element 63. So this is the import process. Hope you understand the basics. Let me know if you have any questions, and I will see you in the next video.